Hello, in this lecture we will find the area of the green triangle. In the drawing we have an equilateral triangle ABC and also we know that AF equals to BF, BD equals to 2 units and DC equals to 4 units, and inside the equilateral triangle we have the green triangle EDF that is also a right triangle because angle EDF equals to 90 degrees. This angle equals to 90 degrees. It is a right angle, and we want to find out the area of the green triangle. Okay, first of all we will find the size of every side of the equilateral triangle ABC. The side of BC equals to BD plus DC. Okay, BC equals to BD plus DC, and BD equals to 2 units and DC equals to 4 units. So actually BC equals to BD, that is 2 units, plus DC, that is 4 units. So in total BC equals to 2 plus 4 units, that is to say BC equals to 6 units. Okay, BC equals to 6 units. Okay, and all the sides of an equilateral triangle are equal to each other, so AB also equals to AC, and they equal to 6 units. Okay, AB equals to AC, that equals to BC equals to 6 units. So we know that all the sides of our equilateral triangle ABC are equal to 6 units. Okay, and we also know that in any equilateral triangle all its angles are equal to 60 degrees. So angle BAC equals to 60 degrees, angle ABC equals to 60 degrees, and also angle BCA equals to 60 degrees, and so we know that side AB of the equilateral triangle equals to 6 units. So we can write here that AB equals to 6 units from one side, but from the other side we also know that AF equals to BF. It is given us in the question that AF equals to BF. So if we define AF as X, then BF also will be defined as X. So actually AB equals to AF plus BF. That is to say AB, side AB of the equilateral triangle equals to AF, that is X, plus BF, that is also X. So actually AB equals to X plus X, that is 2X. So we can write here that AB also equals to 2X. So in total we got this equality that states that AB equals to 6 equals to 2x. So from this equality we can derive this equality that 6 equals to 2x. Okay, we know that 6 equals to 2x, or 2x equals to 6 units. So if we divide this equality by 2, we will get that x equals to 3 units. X equals to 3 units, so we can write here that AF that equals to x equals to 3 units, and also FB that equals to x equals to 3 units. Okay, in the next step we will define FD as A, that is to say FD equals to A, and we will define ED, ED as B. Okay, we will define ED as B, that is to say ED equals to B and FD equals to A, according to our definition. And in the next step we will find out the size of FD that equals to A according to the law of cosines. Okay, so what is the law of cosines? What is the law of cosines? Before I explain what is the law of cosines, I must emphasize the fact that the law of cosines apply to any triangle. Okay, so I write down that in any triangle, so you can use the law of cosines in any triangle. Okay, so actually if we have triangle the blue triangle, and we know that the length of this side of the triangle is A, and the length of this side of the triangle is B, and the length of this side of the triangle is C, and the angle between side A and side B of the blue triangle is theta. Then, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay, so according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay, so we actually can implement the law of cosines in triangle FBD. Okay, so in triangle FBD, FD square equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Again, in triangle FBD, the small triangle FBD, FD square, that is actually A square, equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Okay, FD square equals to FB square plus BD square minus 2 times FB times BD times cosinus 60 degrees. Okay, that is actually the implementation of the law of cosines in triangle FBD. Okay, but what is the value of FD? FD equals to A according to our definition. So FD square is A square equals to FB square. FB equals to 3, so FB square is 3 square, and 3 square is 9, plus BD square. BD equals to 2 units, so 2 square is 4, minus 2 times FB is 3, times BD is 2, times cosinus 60 degrees. Cosinus 60 degrees is 1 over 2. So in total we got that A square equals to 9 plus 4 minus 2 times 4 times 2 over 2. 2 over 2 is 1, so 2 is cancelled. So after we cancel 2, what is left is A square equals to 9 plus 4 is 13, minus 2 times 3 is 6. So we have here the equality that A equals to 13 minus 6. 13 minus 6 is 7. So we got that A square equals to 7. Now we will take a root out of this equality, and we will get that A equals to root 7 units. Okay, so we found out that the value of A is root 7 units. Okay, so I write it down in the drawing that A equals to root of 7 units. Okay, in the next step we will define angle BFD as theta, and we will define angle BDF, this angle, as alpha, and we will define angle EDC, this angle, as gamma, and we will define angle DEC, this angle, as beta. Okay, and we will find out the value of sinus theta according to a new law, according to the new of sines. Okay, so what is exactly the law of sines? Again, first of all, I will emphasize that the law of sines apply to any triangle, so I can write down that in any triangle you can use the law of sines in any triangle. If we have the black triangle and if the length of this side of the black triangle is A, the length of this side of the black triangle is B, and the length of this side of the triangle is C, and this angle is alpha, this angle is beta, and this angle is gamma, then according to the law of sines, the following relationship exists between the sides of this black triangle to its angles: A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, and again it is true for any triangle. So according to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. So we actually can implement the law of sines in our triangle, the small triangle FBD. So in triangle FBD, FD over sinus 60 degrees equals to BD over sinus theta. again, in triangle FBD, according to the law of sines, FD over sinus 60 degrees equals to BD over sinus theta. Okay? But what is the value of FD? FD equals to A, that equals to root 7. So FD actually equals to root 7. And sinus 60 degrees equals to root 3 over 2. All equals to BD equals to 2 units, and sinus theta is the value that we want to find out. So I leave it as it is, and we will find out the value of sinus theta according to our equation that we created according to the law of sines. Okay? So, according to the law of sines, root 7 over root 3 over 2 equals to 2 over sinus theta. Here we can move 2 to the numerator and root 3 to the denominator. Okay, so we'll get that 2 times root 7 over root 3 equals to 2 over sinus theta. Okay, so we got here that 2 times root 7 over root 3 equals to 2 over sinus theta. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so we can cancel 2. So what left after we cancel 2? What left is root 7 root 3 equals to 1 over sinus theta. So what is left after we cancelled 2 is root 7 over root 3 equals to 1 over sinus theta. Here we will multiply the equality by sinus theta. So we actually got that root 7 over root 3 times sinus theta equals to 1. Here we will multiply the equality by root 3, and we will get that root 7 times sinus theta equals to root 3. So here we divide this equality by root 7 in order to get the value of sinus theta. Okay, so we will get that sinus theta equals to 3 over root 7. Okay. So we found out the value of sinus theta. Sinus theta equals to root 3 over root 7. In the next step, we will find out the value of cosinus theta, and we will use the first trigonometric identity in order to find out the value of cosinus theta. According to the first trigonometric identity, sinus theta squared plus cosinus theta squared equals to 1. So we will use this trigonometric identity in order to find out the value of cosinus theta. We have already found out that the value of sinus theta is root 3 over root 7, and we want to find out the value of cosinus theta. Okay, so from this identity we will subtract sinus theta squared, and we will get that cosinus theta squared equals to 1 minus sinus theta squared. Okay. In the next step, we will take a root out of this equality, and we will get that the value of cosinus theta is actually equals to the root of 1 minus sinus theta squared. Okay, so we found out the value of cosinus theta, but we have already found out that the value of sinus theta equals to the root of 3 over root 7 okay. The value of sinus theta equals to root 3 over root 7, so we will square this equality in order to find out the value of sinus theta squared. So the value of sinus theta squared will be three over 7. So we found out that the value of sinus theta squared equals to 3 over 7. In the next step, we will substitute sinus theta squared by 3 over 7 because sinus theta squared equals to 3 over 7, and we will get that the value of cosinus theta is 1 minus the root of 1 minus 3 over 7. So the value of cosinus theta after we substituted sinus theta squared by 3 over 7, cosinus theta equals to the root of 1 minus 3 over 7. 1 minus 3 over 7 is 4 over 7, so I write it down. So cosinus theta equals to the root of 4 over 7. Okay? Cosinus theta equals to the root of 4 over 7. The root of 4 is 2, so I will write it down. So cosinus theta equals to 2 over root 7. So we actually found out the value of cosinus theta, and we have already found out the value of sinus theta. Sinus theta equals to root 3 over root 7. Okay, so we actually found out the value of cosinus theta and sinus theta. Okay, so in the next step we will create 4 equations from this drawing. The first equation, in the first equation we will focus on triangle FBD. So actually the sum of the angles in triangle FBD equals to 180 degrees. That will be our first equation, that the sum of the angles in triangle FBD equals to 180 degrees. That is to say 60 degrees plus alpha plus theta equals to 180 degrees. Okay, so that is our first equation that states that the sum of the angles in triangle FBD equals to 180 degrees. Our second equation, or in our second equation, we will focus on triangle DEC. Okay, on triangle DEC, again the same thing. The sum of the angles in triangle DEC equals to 180 degrees. So we can write down what is the sum of the angles in triangle DEC. It is actually 60 degrees plus gamma plus beta, and it equals to 180 degrees. Okay, again, equation number 2 states that the sum of the angles in the small triangle DEC equals to 180 degrees. In the next step, we will add equation number 1 to equation number 2, and we will create equation number 3. Okay, so equation number 3 is the addition of equation number 1 to equation number 2. Okay, so 60 degrees plus 60 degrees is 120 degrees, plus alpha plus theta plus gamma plus beta equals to 180 degrees plus 180 degrees equals to 360 degrees. Okay, again, the third equation is the addition of equation number 1 to equation number 2. Okay, so here for equation number 3 we will subtract 120 degrees, and we will get that alpha plus theta plus gamma plus beta equals to 360 degrees minus 120 degrees is 240 degrees. Okay? Okay, so equation number 3 states that alpha plus theta plus gamma plus beta equals to 140 degrees. In the next step, we will create equation number 4 that states that in a specific point along a straight line or line segments, the sum of the angles on the upper side of a straight line or line segment equals to 180 degrees. So at point D along line segment BC, the sum of the angles on the upper side of line segment BC equals to 180 degrees. That is to say, gamma plus 90 degrees plus alpha equals to 180 degrees. Okay, so gamma plus 90 degrees plus alpha equals to 180 degrees. Again, equation number 4 states that at a specific point along a straight line or line segments, the sum of the angles on the upper side of a line segment or straight line equals to 180 degrees. Okay, so here we will subtract 90 degrees from equation number 4, and we will get that gamma plus alpha equals to 90 degrees. Okay, so equation number 4 states that gamma plus alpha equals to 90 degrees. But we have gamma plus alpha in equation number 3 also. So we can substitute gamma plus alpha in equation number 3 by 90 degrees because gamma plus alpha equals to 90 degrees. Okay, so we will subtract gamma plus alpha by 9. We will substitute gamma plus alpha from equation number 3 by 90 degrees because gamma plus alpha equals to 90 degrees. Okay, so we'll do it now, and we will get that 90 degrees plus theta plus beta equals to 240 degrees. Okay, according to equation number 3, 90 degrees plus theta plus beta equals to 240 degrees. Here we will subtract 90 degrees from equation number 3 and we will get that theta plus beta equals to 150 degrees. Okay, so equation number 3 states that theta plus beta equals to 150 degrees. Here we will subtract theta from equation number 3 and we will get that beta equals to 150 degrees minus theta. Okay, so from equation number 3 we got that beta equals to 150 degrees minus theta. So actually, if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Okay, so we got the following equality that states that sinus beta equals to sinus 150 degrees minus theta. Okay, sinus beta equals to sinus 150 degrees minus theta. In order to find out the value of sinus theta minus, in order to find out the value of sinus 150 degrees minus theta, we will use the second trigonometric identity that states that the value of sinus alpha minus beta is actually sinus alpha cosinus beta minus sinus beta times cosinus alpha. So we will use this trigonometric identity in order to find out the value of sinus 150 degrees minus theta when we will substitute alpha by 150 degrees and beta by theta. Okay, so what we will get is that sinus 150 degrees minus theta equals to sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. Okay, so we found out the value of sinus 150 degrees minus theta by using the second trigonometric identity. Okay, but what is the value of sinus 150 degrees? The value of sinus 150 degrees is 1 over 2 multiplied by cosinus theta. We have already found out that the value of cosinus theta is 2 over root 7 minus sinus theta. We have already found out that the value of sinus theta is root 3 over root 7 times cosinus 150 degrees. The value of cosinus 150 degrees is minus root 3 over 2. So in total we got that 1 over 2 times 2 over root 7 minus root 3 over root 7 times minus root 2 minus root 3 over root 2 all actually equals to sinus beta. So here we have 2 in the numerator and 2 in the denominator, so 2 over 2 is 1, 2 is cancelled, and we have here minus times minus is plus, and root 3 times root 3 is 3, so I write it down. So in total we got that 1 over root 7 plus 1 over root 7 times 3 over 2 all equals to sinus beta, because we started the equality from sinus beta. So here we can take out 1 over root 7 as a common factor of this expression, and we will actually get that 1 over root 7, and in the brackets we will have 1 plus 3 over 2. Okay, so we got this expression that 1 over root 7 times 1 plus 3 over 2. 1 plus 3 over 2 is 2.5, and 2.5 is 5 over 2. So I will write it down that the value of sinus beta equals to 1 over root 7 times 5 over 2. Okay, so we actually found out the value of sinus beta. Sinus beta equals to 5 over root 7 times 2. Okay, so in the next step, we will implement the law of sines in triangle DEC, in this triangle, in order to find out the value of B. We have already found out the value of A, and after we find out the value of B, we can calculate the area of the green triangle. Okay, so according to the law of sines, in the small triangle DEC, DE over sinus 60 degrees equals to DC over sinus beta. Again, according to the law of sines, in triangle DEC, DE over sinus 60 degrees equals to DC over sinus beta. Okay? What is the value of DE? We define DE as B, so DE equals to B, and sinus 60 degrees equals to root 3 over 2, all equals to DC. DC equals to 4 units, and we have already found out the value of sinus beta. Sinus beta equals to 5 over 2 times root 7. So in total we got that B over root 3 over 2 equals to 4 over 5 over 2 times root 7. Here, in this side of the equation, we will move 2 to the numerator and root 3 to the denominator. In the other side of the equation, we will move 2 times root 7 to the numerator and 5 to the denominator. Okay, very simple arithmetic calculation, and we will get that 2 times B over root 3 equals to 2 times root 7 times 4 over 5. Okay, so we actually got this equality, and here we have 2 in this side of the equation, and we have 2 in the other side of the equation, so we can cancel 2. So what left after we cancel 2 from this equality is, what is left is actually B over root 3 equals to root 7 times 4 over 5. Okay, so after we cancel 2, what is left is B over root 3 equals to root 7 times 4 over 5. Here we will multiply this equality by root 3 in order to get the value of B. Okay, and we will get that B equals to root 7 times root 3 times 4 over 5 units. Okay. So we actually found out the value of b. B equals to root 3 times root 7 times root 3 times 4 over 5 units, and we have already found out the value of a. A equals to root of 7 units. So we found out the values of a and b. Okay, now what is the area of the green triangle? The area of the green triangle actually equals to the base of the triangle, that is b, times the height to the base, that is a. You should remember that the height must create 90 degrees with the base, and the height A indeed creates 90 degrees with the base, because angle FDE is a right angle, it equals to 90 degrees. So it is B times A over 2. Okay, the area of the green triangle FDE equals to the area of the green triangle FDE equals to B times A over 2 or A times B over 2. And we have already found out the values of A and B, so the only thing that is left is to substitute A by root 7 and to substitute B by the value that we have found for B. Okay, so the area of the green triangle FDE will be A is root 7 times B is root 7 times root 3 times 4 over 5, and all divided by 2. Okay, so we found out that the area of the green triangle is this expression, but root 7 times root 7 is 7, and 4 over 2 is 2, so I write it down. So the area of the green triangle FDE equals to 7 times root 3 times 4 over 2 times 5 . 4 over 2 is 2, so I write it down. Here 4 over 2 is 2. So the area of the green triangle FDE equals to 7 times 2 times root 3 over 5. Okay, but 7 times 2 is 14, so I write it down. So the area of the green triangle FDE equals to 14 times root 3 over 5 square units. Okay, so the area of the green triangle FDE equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. Okay, so the area of the green triangle FDE equals to 4.85 square units. Again, the area of the green triangle FDE, this green triangle FDE, equals to 4.85 square units. Okay, now I will summarize the lecture. Actually, we wanted to find out the area of the green triangle FDE that is also a right triangle because of the fact that this angle is a right angle, and we actually know that triangle FDE is inside an equilateral triangle because ABC is an equilateral triangle. That means that all of its angles equals to 60 degrees, and the sides of any equilateral triangle, and especially the sides of triangle ABC, are equal to each other. That is to say, AB equals to AC equals to BC. Okay, and we also know that AF equals to BF, and we know that BD equals to 2 units, DC equals to 4 units, and we want to find out the area of the green triangle FDE. Okay, so first of all, we will find the size of the side of the equilateral triangle ABC, and we will focus on side BC of the equilateral triangle ABC. Side BC equals to BD plus DC. Again, BC equals to BD plus DC. But we know that BD equals to 2 units and DC equals to 4 units. So actually the size of BC is BD plus DC, that is to say is 2 plus 4 units. So the size of BC equals to 6 units. Okay, but because of the fact that all the sides of any equilateral triangle are equal to each other, we can say that AB equals to AC equals to BC equals to 6 units. So we know that AB equals to 6 units from one side, but we also know that AB, the size of AB equals to AF plus BF, and AF equals to BF. So if AF is X, then BF that equals to AF is also X. So AB will be equal to AF that is X plus BF that is also X. Or in other words, AB equals to X plus X, 2X. So from the other side, we know that AB also equals to 2X. So from this equality, you can derive the equality that 2X equals to 6. And we can divide this equality by 2, and we will get that X or X equals to 3 units. That is to say, AF that equals to X equals to 3 units, and BF that also equals to X equals to 3 units. Okay, in the next step we will define FD as A, that is to say FD equals to A, and we'll define DE as B, that is to say DE equals to B, and we will find out the value of DE by the law of cosines. What is the law of cosines? Before I will explain what is the law of cosines, I will emphasize that the law of cosines is true for any triangle. Okay, so in any triangle you can implement the law of cosines. The law of cosines states that c squared equals to a squared plus b squared minus 2 times a times b times cosinus theta. Okay, again, c squared equals to a squared plus b squared minus 2 times a times b times cosinus theta. So we actually can implement the law of cosines in the small triangle FBD. This small triangle, according to the law of cosines, in the small triangle FBD, FD squared equals to FB squared plus BD squared minus 2 times FB times BD times cosinus 60 degrees. Okay, according to the law of cosines, in the small triangle FBD, FD squared equals to FB squared plus BD squared minus 2 times FB times BD times cosinus 60 degrees. What is the value of FD? FD equals to A, according to our definition. FD equals to A. And FB equals to 3 units, so FB squared is 9. BD equals to 2 units, so BD squared is 4. And here 2 times BF times BD is 2 times 3 times 2. And cosinus 60 degrees is 1 over 2. Okay, so the only missing variable here is A, FD equals to A, so we found out that the value of A is root 7 units. Okay, A equals to root 7 units, that is to say the size of FD that equals to A equals to root 7 units. Okay, in the next step, in order to find out the value of sinus theta, we will implement a new rule on triangle FBD, on this small triangle. The new rule is the law of sines. The law of sines states that in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay? So, the implementation of the law of sines in the small triangle FBD is FD over sinus 60 degrees equals to BD over sinus theta. Again, FD over sinus 60 degrees equals to BD over sinus theta. Okay, but we know that FD, okay, so that is the implementation of the law of sines in triangle FBD. FD over sinus 60 degrees equals to BD over sinus theta. But we know that FD equals to root of 7 units, and we know that sinus 60 degrees is root 3 over 2, and we know that BD equals to 2, so the only missing variable is sinus theta. Okay, so we solved this simple equation and we found out that the value of sinus theta is root 3 over root 7. Okay, and then in the next step we found out the value of cosinus theta by implementing a new trigonometric identity, and from that trigonometric identity we found the value of cosinus theta. The new trigonometric identity states that sinus theta squared plus cosinus theta squared equals to 1. Okay, we subtracted from this identity sinus theta squared, and we got at the end that the value of cosinus theta is actually equals to 2/√7, and we have already found out that the value of sinus theta is √3/√7. Okay, then we created 4 equations from this drawing. The first equation states that the sum of the angles in this triangle FBD equals to 180 degrees. That is our first equation. The second equation states that the sum of the angles in triangle DEC equals to 180 degrees. That is our second equation, and we added equation number 1 to equation number 2 to create equation number 3. Okay, equation number 3 is the addition of equation number 1 with equation number 2. And then we created equation number 4 that states that at a specific point along a straight line or line segment, the sum of the angles on the upper side are equal to 180 degrees. Okay, so here at a specific point, that is to say at the point D, the sum of the angles on the upper side of line segment BC equals to 180 degrees. That is to say gamma plus 90 degrees plus alpha equals to 180 degrees. Okay, this is our fourth equation, and from equation number 3 and 4 we got to the third equation that states that beta equals to 150 degrees minus theta. But if beta equals to 150 degrees minus theta, then sinus beta equals to 150 degrees minus theta. Okay, and in order to find out the value of sinus 150 degrees minus theta, we used second trigonometric identity that states that sinus alpha minus beta equals to sinus alpha times cosinus beta minus sinus beta times cosinus alpha, when alpha equals to 150 degrees and beta equals to theta. In this way we found out the value of sinus beta. We found out that sinus beta equals to 5/√7 times 2. After we found out the value of sinus beta, we implemented the law of sines in triangle DEC. According to the law of sines, DE over sinus 60 degrees equals to DC over sinus beta. Again, according to the law of sines in triangle DEC, DE over sinus 60 degrees equals to DC over sinus beta. We know that DC equals to 4 units, DE actually is B, and sinus 60 degrees is √3/2. The only missing variable here is B. So we solved this simple equation and we found out that the value of B is actually √7 times √3 times 4 over 5 units. And we have already found out that the value of A is √7 units. Okay, after we know the values of A and B, we can calculate the area of the green triangle FDE, because the area of the green triangle FDE equals to the base of the triangle that is B times the height to the base that is A over 2. Okay, the area of the green triangle FDE equals to A times B or B times A over 2. And we have already found out the values of A and B, so the only thing that is left is to substitute A by √7 and to substitute B by the value that we got for B, and to divide the multiplication of A with B by 2. Okay, so we did this thing, and we found out that the area of the green triangle equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle equals to 4.85 square units. Again, the area of the green triangle equals to 4.85 square units. Okay? Thank you very much.